Alright guys, welcome to the 1990 question BC3. Let's get started. So this one says f of x equals 2, 12 minus x squared. For when x is greater than 0, f is, okay, so their boundary, this is like the first quadrant, right? Okay, so it says here, the line tangents the graph of f at the point k, comma f of k intercepts at x-axis at x equals 4. What is the value of k? Alrighty, so let's think about that. To do this kind of question, I think it's always nice to see a visual. So in the first quadrant, what is it? X squared minus, okay, so this is, okay, so it's a parabola going down at 12. Let me just write 12 here. But it's only the right half, and then it stops here, and that's going to be the square root of 12, right? Because that's the x-intercept. Alrighty. And then there's a point on this graph, do a different color. Let's say this point here, that has a tangent line with an x-intercept of 4. Okay. Alright, it's not too bad. And the point where the intercept is k, f of k. Okay. So we know this is not such a bad question. It's just a lot of, it's confusing when you first read it, like what? And so now I see the picture, so now I get it now. We're looking for the value of k. What would make sense for k given and this is there? So how would you approach this question? What do we know? And if you guys are stumped or lost for a minute, we know that these two lines share that point. And that's the key. Since they share that point, they share the same y value. So the idea is, I'll call this graph y1, and then I'll call this graph here, I'll put it back to the pink or whatever it is, y2. So basically we want to know, we want to do this. This is what we want to do. That's the idea. Whenever you see these kind of equations or kind of systems, you have to make that situation. You happen to know where they intercept. They intercept when x equals k. So right here. So when x equals k, wherever that k value is, we know the intercept. So it's going to be in terms of k when we do the slope equation, but then, or sorry, the tangent line equation. But then we know what k is. We know what x is, excuse me, so we can plug it in and we can work this out. So let's get started. First things first, we need to know the slope of this y2 in order to find the equation, right? The slope of y2 is going to share the same slope of y1 when x is k. So let's find out the slope of y1. So it's going to be negative 2x, right? So any point on this green graph has a derivative of negative 2x. So what's the slope of that point up here? The slope is going to be negative 2x, and x is k, right? So negative 2k. We also have the coordinate here, and that coordinate is useful. That coordinate is 4, 0. Let me see if I can shrink it. This is 4, 0. So it's going to be, this is for y2, okay? It's going to be y minus y1, which is 0, equals to negative 2k. That's the slope, that's m. Then x minus 4. So this is irrelevant. So it's going to be y2 equals negative 2kx plus 8k. All right. So we have now the two equations. We have y1 equals to, I believe it was 12 minus x squared. And then y2 was negative 2x, blah, blah, blah. And we know they're equal to each other. We know this is true when x equals k, and that's the key thing. We're going to just basically set them equal to each other and plug in k. That's all we're going to do, and then we're going to solve for k when we do that. So we're going to say 12 minus x squared, I'll just put x squared for now, equals to negative 2kx plus 8k. We know this happens only when x equals k, right? That's when it happens. So now, in reality, what it really says is k squared negative 2k squared plus 8k. So now we have the equation in terms of k. We can solve for k now. Let's see. I'm going to move everything to this side, okay? So it's going to be, what is that? K squared minus 8k plus 12 equals 0. We're going to factor this. Let's see, 4 6 times 2. So k minus, I have a temptation to put x every single time. K minus 6, k minus 2, k equals to 6 or 2. Wait a second. Which one? Only one of these will work. Let's see. This is 4. It has to be 2. So k, 6 is too big. K is 2. So we're done. So no k is 2. So let's actually go back and say that in this equation, this tangent line equation would have been y2 equals, what was k again? Crap, 2. So negative 2 times 2, or negative 4x plus 8 times 2, I believe, so it's 16. Boom. Just in case, I'm just putting it up there. I'm not sure if I need it, but let's see. An isosceles right triangle, wait, let me say it right, sorry. An isosceles triangle whose base is the interval of zeros. Okay, so, oh crap, is this another question? Read it again. An isosceles triangle whose base is the interval 0, 0 to 0 to C0 has the vertex on the graph of F. For which value of C does the triangle have a maximum? Oh, okay. This is an optimization question. Okay, so it's basically saying this. We have an isosceles triangle, and remember what isosceles means, that you have two sides that are the same. So, let's see, how would it draw? So this 0, 0, and I'm just going to keep using this. I'm going to pretend it's not there, and C0, and then it has to have a point somewhere on this graph, so that when I connect, so we know it has to connect, like, let's pretend it's here. I'm going to try my best to pretend it's like there, so that these are the same. You know what I mean? It has to be like that, pretty much. So, maybe not necessarily like that, but that's the idea, at least. So if this is that what it says here? Okay, it says has a vertex on the graph of x. Okay, so it can, oh wow, can it technically look like this? I'm curious. Can it look like this? Like boom, boom, really, really wide? And it's like, this is C? I don't know what this could look like. I'm just reading again and again and again, so I'm not sure. I'm just going to go ahead and do it. What is the area of a triangle? Let's just remember that. That's how you do this. This is part A, B, or yeah, part B. So the area of a triangle is half base times height. Now we have to relate the function we know. So the height would be f of c, right? This would be f of, or some point. We'll call it c for now, okay? We know that, at least we hopefully know that. Let's just see. So it's going to be 1/2 the base. What's interesting, because if I put it, oh crap, so this is a tough one. Let me draw it again. So if I have a graph like this, and I say this is my point, then, crap. Well, I guess it has to be half a c. Yeah, I was thinking it's gonna, so okay, I take it back. I said it was gonna be c, didn't I, here? It's half c, because it's gonna have to double like that. Yeah, it's gonna touch a c. Okay, wow, so you really gotta draw this one. So c, half of c, and it's gonna be f of c half. Okay, so now we know that it's gonna be, the base itself is going to be c. You can call it c, right? That's the whole base. And then we can say that the height of it would be the equation of f of c halves. The equation, I believe, was 12 minus x squared. So it's going to be 12 minus c over 2 squared. And I believe that makes the most sense. And this is the area, obviously. So we're going to go ahead and clean this up a bit. This is 12 minus c squared over 4 times c over 2. I'm going to distribute this. I'm going to get the area equals to 6c minus c cubed over 8. Yeah. And now we're going to get the derivative. A prime equals to 6 minus 3c squared over 8. Make it equal to 0. Oh my gosh. Okay, so let's see. This is going to be 3 squared over 8 equals to 6. 48, I believe, then divide by 3, so it's 2, 16, and then c equals 2 plus or minus 4, which obviously it only should be 4. Okay, oh gosh, finally. Let's see, what does it say here? So, what the maximum value justify your answer? So we found that the critical value is at C, F4. So it has either an absolute min or an absolute max, I guess. So we're going to test that boundary. We're going to say here's 4, here's the derivative, right? The derivative is 6 3c squared over 8, and we're going to test it. Let's plug in 0. So 6 minus 0 is positive, and then let's plug in 5. Let's say, oh crap, 5 squared 25 times 375 divided by, calculator, man, I forgot this. 75 divided by 8 is a number bigger than 6, so it's going to be negative. So that it's going to go from increasing to decreasing. This is the max, right? This means that it's an absolute max. So, gosh, come on, my computer's freezing again. So it says here, for what value of C does it try to just for answer? Okay, so how would I write this? The area is maximized when C equals 4 by first derivative test, I guess. Usually you have to say it goes from increasing to decreasing. Whatever. I think that's good enough. I'm just gonna say like that for now. Alrighty, guys. I hope this helped. This is a tougher question. It is a BC question, but it really made me think a little bit. The image of the drawing. This is the part that kind of got me for a second. So make sure you guys, if they ask questions like this, you draw, and I hope that this will help you guys, for the actual test. I'll see you guys soon.